Hi everybody, this is the fourth video. It covers exercise 7 from section 2.5. And in this video we find the local extrema of the function square root of x squared plus y squared, which is a little different from the first three videos, which only looked at polynomials in x and y. So, first thing is that, well, square roots in calculus are generally not our friend. So we rewrite this as x squared plus y squared to the 1/2, which should help us when we're trying to find the gradient of the function. Alright, so finding the gradient, okay, we'll take a derivative and we'll get 1/2. Oh, we seem to be missing the 1/2s, don't we? Oh, no, we don't. We'll get 1/2 x squared plus y squared to the negative 1/2, but then we have to multiply by the derivative of the inside, which would be a 2x. So that 2 and the original 1/2 we had will cancel out. And so in the x direction we get x times x squared plus y squared to the negative 1/2 power. And since this function is symmetric in x and y, we know that the derivative in the y direction will be the same thing, only I replace all my x's with y's. Alright, now where is this thing going to be 0? Well, it's going to be a lot easier if we rewrite it now with square roots, because now they're going on to the bottom, and if we want fractions to be 0, of course we want the numerators to be 0. So the only way that's going to happen is if x and y are going to be 0. But, oh, if x and y are both 0, we get zeros in the bottoms of these fractions. So that's bad. Yeah, not gonna work there. But now we remember something. Critical points occur when the gradient is 0, but they also can occur when the gradient is undefined. And that we do have. X equals 0, y equals 0, the gradient is undefined. So the only critical point will be 0, 0. Okay, so now we want to see if it's a local min or a local max. And so we think naively, well, okay, let's whip out our second derivative test, but already we're going to have a problem. Even the first derivatives, alright, the first partial derivatives weren't defined at 0, 0. So we're not going to be able to compute any of these values. What can we do? Oh, no, not think. That's always dangerous. Okay, well, let's think about this point 0, 0. If we plug that into the function, we're going to get 0 out. And if we think about it for just a moment, we realize if we plug in any other values for x and y, it's going to have to be bigger than 0. If x is negative or positive, it's going to give you some value here. And you're adding to it some other positive value here. So all we're going to end up with is some positive number. We take the square root, we get a positive number. Definitely bigger than 0. So this 0, 0 must, in fact, be a local minimum. Even a global minimum, if you like. Alright, so that ends up being the answer. F is a local minimum at 0, 0. We don't need to use the second derivative test here. We just have to use our brains, which is, of course, not something we like to do very often, but if you must, then you must. If you want to look at the video for one of the other problems, you can click on the link on this page.